Okay. Okay. Thank you, Triveni ma'am, for the introduction. Good afternoon to everyone, and welcome to the webinar on rapid photorealistic 3D modeling done for cave. And Okay, so a short introduction about me. I have done my BTech in computer engineering from Institute of Engineering, Pulchar campus, Tribhuvan University. I've been doing research in computer vision and 3D reconstruction. I'm also a co-founder and CEO of our startup New AI. And recently, I was also a part of the India-Nepal Startup Partnership Network INSPAN program, which was organized by IITM Pravartak and facilitated by the Embassy of India in Kathmandu, and I got the opportunity to stay at IIT Madras for 2 months. And during my stay, I also got to work at the XTIC lab with Professor Manivanan. So in any kind of if you want any kind of digital or virtual experience, the core thing that we need is a 3D model. So the experience can be anything like a game or a virtual tour or some sort of any sort of AR or VR experience. We need 3D models. Different time it could be of the environment or of the character or different objects. So creating 3D model itself is a very painful process. First, you have to create a 3D model using Blender or AutoCAD or any other tools. You have to handcraft and sculpt all these 3D models. You have to bake the textures, and you have to manually give all the materials and set the lightings, and then after hours of work you will get somewhat these kind of results. So this process is very time consuming, and it requires some 3D modeling experts, and it's a very expensive process, and the main challenge is that to make it look very realistic, it is very difficult. So one solution could be is to use an image-based approach. Basically, from images, you can create 3D models. So in this case, the 3D model in this the 3D modeler or the 3D artist is the camera itself. So one of the most widely used image to 3D model tool is called photogrammetry. So in photogrammetry, using just a set of images, you can create these 3D models. And there are various kind of tools like Metashape and Reality Scan to do these. Uh, but the problem with this is that you'll get very heavy and very messy kind of meshes, and the performance using these kind of meshes is very poor, and it does lack the realism aspect as the models look quite flat. So another approach is using something called the neural radiance field. So what it does is basically it tries to using a neural network. It tries to create a 3D of the whole environment, and the using volumetric ray tracing technique. The whole 3D scene is represented by a basically a neural network. So with this neural radiance field, we can get these kind of very realistic rendering. But the problem is that compute requirement is very high, and even on a very powerful setup using powerful CPU, the rendering is quite slow. Like you can only get 3 or 4 FPS. So even though the quality is there, even though the realism is there, it is not practically usable. So then came technology called 3D Gaussian splatting technology that we are going to more or less focus on more on this webinar. So in order to understand it in quite easy way, 3D Gaussian splatting is basically like a point cloud. It's basically a point cloud with different parameters, extra parameters. Like these point cloud have their own scales, rotation, and opacity values. So basically, 3D Gaussian is approximated by a 3D ellipsoid, and using these ellipsoid of different color and opacity values, and using millions of these ellipsoid, the whole 3D scene can be represented. And that is the basic idea of 3D Gaussian splatting. So using this technique, we can get very realistic rendering, and the performance is also quite good. We can easily get real-time rendering, and the most important part that it easily integrates into existing 3D pipeline. So this is a very viable solution. And in the 3D Gaussian splatting, so the research paper itself came out only 2 years back, but ecosystem is gradually starting to catch up. And even the big companies like the Meta, Apple, Snap, and even Adobe have started introducing 3D Gaussian splatting in some of their solutions. And there are also some dedicated tools that have been created to work with 3D Gaussian splatting. And just few days back, the Kronos group even added Gaussian splatting support for the GLTF and GLTF GLTF file format. So, our company New AI, we have also created a product tool called Capture Studio to make it very easy to work with Gaussian splatting. So basically, what it does is it allows anyone to turn their images and videos into a 3D immersive experiences, which looks quite realistic. So we have our own 3D reconstruction engine and all the tools that you need to create an immersive experience from images. We have all the tools in it, so it's an all-in-one platform, and it's a fully web-based platform, and it works on any devices. So how it basically works is you need to first capture a video or a set of overlapping images. So you move around the scene like this. So it's one of the scene from the IIT Madras campus. You just take your smartphone and capture the videos from different heights and different angles, and then you just upload it to Capture Studio, and the reconstruction will algorithm will automatically run our cloud. And from just videos, you can get this level of 3D environment, which looks quite realistic. So not only the 3D reconstruction or 3D model, we can even create a fully immersive interactive experience that can be easily shown in the browser like this.
Every
So I'd like to show us a brief trailer of Capture Studio right now.
Every day we capture the world around us. A cozy corner of a cafe, a handcrafted statue, or a hotel room you once stayed in. Photos are all great, but what if we could do more? What if your captures were in 3D? Introducing Capture Studio, a unified platform to convert images and videos into interactive 3D experiences. First, just take a bunch of photos. Move around the scene, get shots from different angles and a few different heights. Upload them to Capture Studio, and your images will be converted into a realistic 3D scene. And that's just the beginning. You can adjust light, color, and tone as you like. Select parts of your scene precisely using our wide range of tools. You can then clear, move, or duplicate any part of your 3D scene effortlessly. There's more. Bring your scene to life by adding images, videos, labels, or even a mesh to create a unique composition. Go beyond just showing a scene. Tell a story. Set viewpoints to guide the flow, fine-tune the transitions, include narration, and add any supporting text or visuals. Simple, clean, 3D storytelling. Once you're done, sharing is a breeze. Just publish your project, send the link, and anyone can walk through your viewpoints, interact with the scene, and explore everything you've created. You can even integrate these experiences in your own websites. And oh yes, you can also explore the experiences created by the community and publish yours too. Capture Studio, a new way to immerse.
So based on the expression of interest Google form that we submitted, we noticed that a lot of the companies and a lot of the interested companies, they use Unity as a platform. So we have developed a Unity package to support these Gaussian splattings and so that they can create their environment in Gaussian splatting and use it in their own projects. So basically, we have created a package for the rendering. You can simply install it in your any existing projects, and you can import the Gaussian splat file. And during import, it will convert it into a suitable format. Then you can create an empty object and just add a renderer script and just assign the asset to it, and then you can see these environments loaded in your Unity platform without any friction. So similarly, we also export a simple collision mesh with the Gaussian splatting. And you can use this collision mesh to interact with them to create some sort of physics simulation or basic collision on top of the so Gaussian splatting would be used for the rendering, for the photorealistic rendering. And if you need some physics and you need some collision experience, then we have a separate collision mesh for it. And we also have, keeping the performance in mind, we also have give two versions of Gaussian splat. One is SD and one is HD. The standard definition, the high definition version is around 25 MB, while standard definition is only around 2 to 5 MB. So if performance is critical in an application like for VR or AR experience, then you can use the standard definition version to get a better FPS, better performance. And that's it from my side. So if there are any question, I'd be happy to answer them.